So, you have been visiting a distant planet. Your measurements have determined that the planet's mass is twice that of the Earth, and the freefall acceleration is 1/4 that of the Earth's. So our question is, what is the planet's radius, and how fast does your rocket need to go to leave the planet? So first, we got to figure out what is our planet's radius. Now, we can use our helpful equation for determining our gravitational acceleration, which looks something like this. The gravitational acceleration of the planet is equal to the gravitational constant times the mass of the planet divided by the radius of the planet squared. So this is great, except it's a little problematic because we don't have the mass of this planet, nor do we have the gravitational acceleration of this planet. What we do have is it's how big it is in comparison to that of the mass of the Earth, and how fast the acceleration is in comparison to that of the Earth's. So from these numbers, which can be retrieved off of Google, we can say that since the planet's mass is twice that of the Earth, that our mass of our planet is going to be equal to twice the mass of our Earth. And we can also say that since our free fall acceleration is 1/4 that of the Earth's, we can say that our free fall acceleration of our planet is equal to 1/4 that of the Earth's, gravitational acceleration of the Earth's. And we can plug these numbers into this equation, which looks something like this. We have 1/4 GE is equal to gravitational constant times 2 mass of the Earth divided by radius of the planet squared. And we just plug numbers in from here. Though if we want to make it a little simpler and get the radius of the planet on one side of the equation, we can do that with some algebra. It's not too hard to figure out, which gives us this equation. The radius of the planet is equal to the square root of 8 times gravitational constant times mass of the Earth divided by gravitational acceleration of the Earth. Again, that's a bad G. It's like, okay, there. So you can kind of see what I did here from this step to this step. First, multiply on both sides to get RP squared over here. Divide by both sides, 1/4 times GE to get this equation, 8 times G times ME divided by GE, and then square root both sides. And we just put numbers in. We get something that looks like this. 8 times G, which can be seen here, 6.6 times 10 to the negative 11. Times mass of the Earth, which is 5.972, times 10 to the 24th, all divided by our gravitational acceleration of the Earth, which is 9.8. And you can plug that into your calculator and get the answer, which is, we're just going to put it over here for now, our radius of our planet, which is equal to 1.8 times 10 to the 7th meters. Okay, now we're going to need this number for the second part, so I'm just going to go ahead and erase this really quick. So that we can do the second part, which is finding out how fast we need to be going to leave the planet. Now this is kind of a tricky question, and we have to ask ourselves, how much energy do we need to overcome the gravitational potential energy of this new planet? And you can look at your gravitational potential energy equation, which says that your gravitational potential energy, right, gravitational potential energy is equal to the gravitational constant times m of your mass, your rocket, mass of your rocket times the mass of the planet divided by the radius of the planet. Okay. We need our kinetic energy to be equal to this. So that looks like this, right? Kinetic energy to be equal to gravitational times the mass of our rocket. This is a little too high. Gravitational times the mass of our rocket times the mass of the planet. Mix that up again. Okay, radius of the planet. What do we know from kinetic energy? What formula do we have that we all know and memorize by now? 1/2 mass times velocity squared is equal to this equation. G times mass of our rocket times mass of the planet divided by the radius of the planet. Mass here is us. That's the rocket. Mass of the rocket. So we want to do algebra. We're going to multiply both sides by 2 here. We get 2. And we would divide both sides by the mass of our rocket. Get rid of that in here. So that's just going to be mass of the planet now. And our final equation is going to look something like this, where we have square rooted both sides. It's kind of messy, but that's your general equation to find how fast we need to be going to leave the planet. And from here, we can just plug numbers in again. So if we come up here, we can say that the velocity we need to leave the planet is going to be equal to the square root of 2 times our gravitational constant, which is 6.6, 7 times 10 to the negative 11th, multiplied by the mass of our planet, which remember is 2 times the mass of the Earth. So I'm just going to put ME here because I'm running out of room. We know that the mass of the Earth is 5.972 times 10 to the 24th, all right? Divided by the radius of our planet, which we determined in part A over here. So that's going to be 1.8 times 10 to the 7th meters. And we can kind of plug this into our calculator, and we'll get the answer. We need to be going 9.4 kilometers per second to leave the planet. That is our final answer. So the velocity of escape, if I can spell escape correctly, escape is equal to 9.4 kilometers per second. All right, that's it. So now we need to stop the